What if I told you that reality itself could soon be rewritten, not by some cosmic event or alien intelligence, but by a single leap in technology? Imagine a computer so powerful that it doesn't just process data, but bends the very fabric of existence. A machine capable of solving the unsolvable, unlocking the deepest secrets of the universe, and even challenging the nature of time and space. This isn't a scene from a sci-fi movie. It's happening right now. Meet the Majorana 1000-qubit quantum chip, a breakthrough so profound that physicist Michio Kaku believes it could alter the course of humanity forever. But with great power comes an even greater risk. Are we about to step into a golden age of limitless possibilities, or are we opening a Pandora's box we can never close? Imagine waking up tomorrow in a world where nothing is the same, not because of war, politics, or natural disaster, but because of a single technological breakthrough. A computer so advanced that it doesn't just process information, it bends the very fabric of reality. A machine capable of solving problems that have baffled scientists for centuries, unlocking the secrets of the universe, and even challenging our understanding of time, space, and consciousness itself. This isn't a scene from a science fiction movie. This is the dawn of the Majorana 1000-qubit quantum chip, a groundbreaking invention that physicist Michio Kaku believes could alter reality as we know it. But with such immense power comes an equally staggering risk. Are we on the verge of a new era of limitless possibilities, or are we about to open a Pandora's box we can never close? For decades, quantum computing has been the holy grail of technology, a futuristic concept promising unimaginable computational power, yet always just out of reach. But now, that future is knocking at our door. The Majorana 1000-qubit quantum chip isn't just an incremental step forward, it's a radical leap into uncharted territory. Unlike classical computers that rely on binary bits, quantum computers harness the bizarre principles of quantum mechanics, allowing them to process information in ways that defy logic. Renowned physicist Michio Kaku describes this breakthrough as more than just an advancement in computing. He sees it as a gateway to rewriting the fundamental laws of physics. This chip could accelerate artificial intelligence, crack even the most unbreakable encryptions, and simulate complex systems with an accuracy never seen before. But the implications go far beyond mere technological progress. If quantum computers can simulate reality down to its smallest details, what does that say about the nature of our own existence? Are we, too, living inside a grand simulation? With the potential to unlock parallel universes, revolutionize medicine, and shake the very foundation of cybersecurity, the Majorana 1000-qubit quantum chip is not just a scientific marvel. It is a force that could reshape the world as we know it. But as with any great power, the question remains, are we truly prepared for what comes next? The quantum revolution, a new era of computing. To understand the significance of the Majorana 1000-qubit quantum chip, we first need to grasp the fundamental difference between classical computers and quantum computers. Classical computers, the kind we use every day, operate on bits, tiny units of information that can be either a 0 or a 1. These bits are the building blocks of all digital computation, from your smartphone to the most powerful supercomputers on Earth. Quantum computers, on the other hand, operate on qubits. Unlike bits, qubits can exist in a state of superposition, meaning they can be both 0 and 1 simultaneously. This allows quantum computers to perform many calculations at once, unlocking a level of computational power that's unimaginable with classical systems. But that's just the beginning. Quantum computers also leverage entanglement, a phenomenon where qubits become interconnected, allowing them to influence each other instantaneously, no matter how far apart they are. This means quantum computers don't just compute faster, they compute in parallel universes. So, how much more powerful is a quantum computer compared to a classical one? The answer is infinitely more powerful. While a classical computer solves problems step by step, a quantum computer explores all possible solutions simultaneously. This makes it ideal for tackling problems that are currently unsolvable, from simulating complex molecular structures for drug discovery to optimizing global supply chains. But there's a catch. Quantum computers are incredibly fragile. Qubits are prone to decoherence, a phenomenon where they lose their quantum state due to environmental noise. This has made large-scale quantum computing unreliable, until now. The Majorana breakthrough. Stability meets power. Enter the Majorana 1000-qubit quantum chip, a revolutionary advancement that could finally make large-scale quantum computing a reality. Unlike traditional qubits, which are highly susceptible to errors, Majorana qubits are based on exotic particles known as Majorana fermions. These particles have a unique property. They are their own antiparticles. This means they can cancel out certain errors on their own, making them inherently more stable than traditional qubits. This stability is a game changer. Current quantum computers struggle with decoherence, which limits their practical applications. But Majorana qubits could eliminate this issue, paving the way for quantum systems that outperform classical computers in real-world scenarios. From unbreakable encryption to simulating molecular structures for advanced medicine, the possibilities are endless. But the implications go far beyond practical applications. The way Majorana qubits work could challenge everything we know about physics and reality itself. According to Michio Kaku, quantum mechanics isn't just a branch of physics, it's the key to understanding the deepest mysteries of the universe. A fully functional quantum computer wouldn't just process information, it could simulate the very fabric of reality. Rewriting reality, the implications of quantum supremacy. The Majorana 1000-qubit quantum chip isn't just another scientific milestone. It's a potential reality-altering breakthrough. Some researchers believe this technology could prove once and for all that we're living inside a simulation. If a quantum computer can perfectly replicate the laws of physics, what's stopping it from simulating an entire universe? This idea, once relegated to science fiction, is now being taken seriously by some of the world's top physicists. But that's just the beginning. Quantum mechanics suggests that particles can exist in multiple states at once, a core idea behind the many worlds interpretation. If quantum computers can process infinite probabilities at once, could the Majorana chip be the first step in detecting or even interacting with parallel dimensions? The implications are staggering. What if this chip doesn't just compute reality, but exposes alternate versions of it? And then there's artificial intelligence. Some believe that true AI will never be possible with classical computers, as they lack the complexity of the human brain. But quantum computing operates in ways eerily similar to how neurons process information. If this technology advances, could we be looking at the birth of sentient AI, a machine that doesn't just process data, but thinks, feels, and learns like a human? The risks. A Pandora's box of possibilities. Not everyone is celebrating this breakthrough. Some scientists are sounding the alarm, warning that the risks of quantum supremacy could be just as profound as its potential. The most immediate concern is cybersecurity. Modern encryption protects everything from bank transactions to military intelligence, but quantum computers operate on an entirely different level. If the Majorana chip becomes fully operational, it could crack encryption methods in seconds, rendering today's cybersecurity useless. Governments, corporations, and entire economies would be left scrambling to develop new quantum-proof defenses. Beyond encryption, there's a deeper concern. What happens when quantum computers can simulate complex systems with complete accuracy? Weather patterns, financial markets, even human behavior, everything could become predictable or, worse, manipulable. Some scientists fear that these simulations could spiral out of control, leading to unintended chaotic real-world consequences. Michio Kaku has long warned that technology advances faster than society can regulate it. Just like nuclear power, quantum computing holds unimaginable potential, but without proper oversight, it could become humanity's greatest liability. If Majorana qubits truly unlock the full power of quantum mechanics, are we prepared to handle the fallout? Is this a Pandora's box moment? Once quantum supremacy is achieved, there's no going back. The race for quantum dominance. The race for quantum dominance is already underway. Tech giants like Google, IBM, and Microsoft are pouring billions into integrating Majorana qubits into practical quantum computers. Governments are scrambling to secure their digital infrastructure, while private companies rush to develop quantum-resistant encryption before it's too late. What's coming in the next 5 to 10 years? If progress continues at this pace, we could soon see fully quantum-powered AI capable of processing information beyond human comprehension. Encryption as we know it will become obsolete, forcing a complete rewrite of global security systems. Meanwhile, scientists could use quantum simulations to decode the most perplexing mysteries of the universe, from the origins of the cosmos to the fundamental nature of reality itself. Quantum computing is no longer science fiction, it's happening right now. But the real question is, are we ready? Is quantum computing humanity's greatest breakthrough, or a dangerous step into the unknown? The answer may depend on how we choose to wield this extraordinary power. The future of reality. The Majorana. 1,000-qubit quantum chip represents more than just a technological leap. It's a gateway to a new understanding of reality. From unlocking parallel universes to creating sentient AI, the possibilities are as thrilling as they are terrifying. But one thing is certain. The future of science is unfolding faster than ever, and the decisions we make today will shape the course of history. So, what do you think? Is quantum computing humanity's greatest breakthrough or a dangerous step into the unknown? Let us know your thoughts in the comments. And if you love exploring the cutting edge of space, quantum physics, and groundbreaking discoveries, make sure to hit that subscribe button. We bring you the most mind-blowing scientific breakthroughs every week, and don't forget to turn on notifications so you never miss the next big revelation. Because the future of science is here, and it's more exciting and more uncertain than ever before.